in Projectile Motion by Brandon and Nahum.
Like energy, momentum is a conserved quantity, meaning that energy can't be created nor destroyed. The product of mass and velocity.
Momentum is a vector, meaning that it has magnitude and direction.
We'll be using several notations. M equals mass and is notated by kilograms. V equals velocity and is notated by meters per second. The arrow above V represents that velocity is a vector. P equals momentum and is notated by kilogram meters per second.
And here is just the formula. P equals mass times velocity, and they're denoted symbols.
The formula for conservation of momentum is final momentum equals initial momentum.
Now to the second part of this lesson, projectile motion, which basically means that when an object is launched off of a height horizontally, the force of gravity will pull it down to the ground in a curved-like motion, a parabola-like motion.
Horizontal and vertical motions are independent, meaning that they do not rely on each other.
And the equation explaining that is delta x equals v naught t plus 1/2 at squared, which are broken into x and y components. Since there's no acceleration in the x, it is delta x equals v naught t, and since there's no initial velocity in the y, delta y equals 1/2 at squared.
Delta x notates the displacement in the x direction, and delta y notates the displacement in the y direction. T notates time, and it is represented by s. V naught notates initial velocity, which is represented by meters per second. A notates acceleration, which is represented by meters per second squared.
And the question, a bullet of mass m is moving horizontally with a speed initial velocity when it hits a block of mass 100 m that is at rest on a horizontal frictionless table, as shown in the next slide. The surface of the table is a height h above the floor. After the impact, the bullet and the block slide off the table and hit the floor a distance x from the edge of the table. Derive expressions for the following quantities in terms of m, h, initial velocity, and the appropriate constants.
Here is the diagram which represents the question before.
Part A asks for the speed of the block as it leaves the table. Here you will use the conservation equation, final momentum equals initial momentum. You break them down into their two variables. What you have then is 101 m final velocity equals m initial velocity. Divide both sides by 101 m and you get final velocity equals v naught over 101 since the m's cancel out. Okay.
The change in kinetic energy can be found through the equation delta k equals kf minus k naught. This is further broken down by 1/2 mf times vf squared minus 1/2 m naught v naught squared. And by plugging in the variables, we can see that the final mass, we plug in the final mass, which is 101 for mf, the final velocity, which is v naught over 101 squared, and we subtract it from 1/2 mv squared. And then we further break it down through basic algebraic expressions, and we are left with this equation. We simplify it by dividing both sides by 2.
The next step calls for finding the distance of x. which you first do by finding time in the y direction, since time in the y is equal to time in the x. Since there's no initial velocity, you plug in your variables and get h equals 1/2 gt squared. Next, you'll divide both sides by 1/2 g, and you'll get 2hg equals t squared, and you will then get the square root of that as seen here. You then take that t and plug it into the delta x equation, and since there's no acceleration in the x direction, you'll be left with x equals v naught over 101, which is the velocity we found in part A, times the square root of 2h over acceleration due to gravity. Now, suppose that the bullet passed through the block instead of remaining in it. How would this affect the time it took to reach from the table edge to the floor? And it just happens to be that the time will be the same because the mass does not affect the time in the y direction, meaning that no matter how heavy or how much matter there is, ty will always equal tx. So as you see here, mass does not affect the delta y equation. The only variables you have here is h and g, which is acceleration due to gravity.
Alright, now state whether the distance x for the block would now be greater, less, or the same. Justify your answer. Delta x can be found through the equation velocity times time. The velocity of the bullet when it contacts the mass is less than the velocity of the bullet before it contacts the mass.